part of why we're getting a lot of our produce from other places. But look at the amount of subsidies that's happened there. Here's down in Long Beach, California. These are oil wells. There's a big, huge oil field under Long Beach. And in this case, this was the surface of the land when these wells were put in. And it is subsided as they pumped the oil out, just like an aquifer with water, same thing. The ground is subsided. So now, these wells are sticking way up above the surface, and they've had to build this dike in here to keep the Long Beach harbor from flooding into the lands. Today what they do is when they produce oil out of the Long Beach field, they pump water back in. So for every barrel of oil they take out, they pump a couple of waters a barrel of water in. Because the water will just sink to the bottom in the reservoir. The oil will float on top of it. They can still recover the oil. But by putting the water back in, they keep the pore system from collapsing. And it slows up or eliminates the subsidies. And here's, of course, the Leaning Tower piece. And the Leaning Tower started to lean before they even finished construction. And they had simply built it in an area where the ground was a little unstable, and as they were withdrawing water for the wells for the town, oversheet started to go. And you can see they're trying all sorts of things to keep it from falling over. Notice the cables here, tying it to the other building next door. And they're still working on it. So far, looks like it wasn't bad. Well, we talked about the cone of depression from the top, but here's one case where I could cone the well up from the bottom. Here I am by the coast, and I've got this saltwater wedge coming in under the land. Salt water being much more dense than fresh water, so it's going to infiltrate, but it'll keep getting lower and lower as I come in under the continent. Now I put a pump in here and I start pumping my fresh water. Well, there's my cone of depression on the surface, but I put the pump way down here toward the bottom of the reservoir, so I could cone the heck out of the thing and pump it really hard, and the cone of depression would come down, and I'd still have a well. The problem is it also cones up from the bottom, and I ended up coning it, or it allowed the salt water to come up, and now I'm sucking up salt water instead of fresh water. So what I should have done was I should have set the bottom of the well somewhere in about the middle of the reservoir, and I should have lowered the pumping rate so it didn't cone. And this is our big thing, now we have these landfills. That's how we get rid of our waste. They look better, and we're going to have all this smog and soot in the air and everything. But there is no such thing as a landfill that doesn't leak. Even with clay liners and plastic sheeting and everything, one way or another, these guys are going to leak. And as that leachate comes out of the landfill, it's going to get into the groundwater, and off it goes in the direction that the groundwater is flowing. And it's not just a plume in that direction, but it starts to spread out laterally, so it is literally a sheet, a big, huge plume. And the only way you can fix this is to put wells in, capture that groundwater, put it through a treatment plant, clean it up, send it on its way. Once the dump's there, the landfill's there, the only way you can get rid of the source, dig it all up and take it away. Where are you going to put it? Repeat the process? It's not simple. There are a lot of us. We use a lot of water. Think about how many gallons of water you use every day. I mean, it's tens of gallons of water per person per day. But by far, the biggest use of water is agriculture. And you see these things out in the fields all over the place around here. These big, huge pumps, sprinkler systems running around, they use about 41% of all the groundwater. We only use about 10%. So for all the water we use, it's kind of minuscule. One of the places where we grow most of the wheat in this country is the Great Plains, breadbasket of America. We export wheat to just about the entire world. And it's part of what keeps our balance of trade in line, our balance of payments. And it's all being run by the Oglala Formation, which is a big aquifer that runs from Texas up to South Dakota. But now, we've gotten that pumped down so far that we probably only have about 20 years of water left. And it's going to take literally thousands of years for it to fully recharge.
What about that?
What are we going to do?
Millions of
What are
years.
the options? Got millions of problems.
The water ain't one.
Yeah, we don't have any, that's not a problem.
Boom!
Your last question.
He's always clowning on us.
Okay, possible environmental pressures that can impact groundwater include
You can move all that has to go.
100%.
20 seconds, this should be pretty obvious.
It's
I
A.
think everybody's gonna figure it's all of the above.
Damn, we still got 3 seconds.